All right, let's look at part 2, where we describe the energy of an object and how it can transform or transfer that energy. So, energy transformation is where we're going to start. And let's just recall that energy could be transferred or transformed. And let's just look at these two words here. The word trans means change, and the word form is like a type. So if you change type, that's transform. So energy transformation occurs when energy changes form or type. So you got a golf ball here that's rolling on a green, and it has kinetic energy. And as it rolls up this hill, it goes up in height and now has gravitational potential energy. When this golf ball, try to get this golf, I took the green with me. I always try to animate and it never goes well, but you know what? I always try anyways. So the golf ball rolls up, and now, if this was like a physics question, it would be at time 1 the golf ball had kinetic energy, and at time 2 the golf ball had gravitational potential energy. So you could say that the golf ball transformed its kinetic energy into gravitational potential energy. So the golf ball transformed its kinetic energy into gravitational potential energy. And that's just practicing the language. Like, how do we describe the energy of an object? That's kind of what we're aiming at here. So here we have, what's the show called? Hunger Games. Here's Catnip. She is Catnip. Is that her name? Definitely not. Well, we'll keep it. Catnip is she pulled back this arrow, and remember that this band is sort of elastic, and there's some energy now stored in this elastic band. So we have elastic potential energy. So I'll just write elastic potential energy, and Catnip releases the arrow, and it flies, and it's got a ton of velocity, and it now has kinetic energy. So aside from just mentioning the forms of energy, now I want to put it into a sentence. The elastic potential energy is transformed into kinetic energy. The elastic potential energy of the arrow is transformed into kinetic energy. So that I want you guys to practice using the word transformed in different scenarios. Good job, Catnip. Okay, so let's talk about energy transfer. So we use a new physics word here. It's called work. And work is energy transfer. Another way to say that is that work, let me just, right here, work, back, zoom, handwriting, engage. Work is equal to the change in energy that an object experiences. So let's think about this. Oh yeah, and we have this awesome formula. So work is your force times your distance. So if this guy picked up a dumbbell off the ground, he uses a bunch of he uses his muscles, and he exerts a force, and he pushes that dumbbell this distance, which is now at a height. He now gives that dumbbell gravitational potential energy. And we could calculate how much energy that is if we knew the force, and we multiplied that by the distance that he picked up that dumbbell, that barbell. Let me keep the color scheme the same. It was like a light green. Force times distance equals work. So let's say that he pushed that dumbbell up twice the distance. Let's just say that he brought it up even higher, twice the distance. If he had twice the distance, it would be twice the work. Twice the distance. He would have done twice the work. Twice the work. Let's say he exerted twice the force. That's 2 twices. So he would have done 4 times the work. So twice the distance and twice the force, he's done 4 times the work. 4 times the work. So this formula just helps you think about how much energy you're putting into these objects. All right, the law of conservation of energy. Now, this is a big idea, and let's introduce it here. So here's an associated concept, and it really ties into when energy transforms or transfers. So the law of conservation of energy states that energy cannot be created or destroyed. It is conserved. And remember, like, conserve nature means to keep it the same. We're not going to change it. So let's say I've got this. This is a device. It's called the Newton's cradle, and I wonder if I can pause it when it, boop. Yeah, there we go. So now the that sphere over on the far right, it has been brought up to a height. So if I were to do that with my hand, I would bring my hand and I would grab that little sphere to the right and I would bring it up, and I've done work. I've exerted a force over a distance, or exerted a force through a distance, and now that sphere has energy. It's got gravitational potential energy. And when I release that sphere, now this system, if this was like a closed system, this Newton's cradle would be doing this action forever, because the law of conservation of energy states that energy cannot be destroyed. So the energy that is in this system, it's going to stay in this system. And that's kind of cool. That helps us solve a lot of problems. Now, of course, because it's not a closed system, and anytime these spheres collide with each other, it creates heat, which leaves the system in the form of thermal energy. Because the heat leaves the system, these spheres will eventually stop moving. But if this were a closed system, if we didn't lose heat energy at all, then we could assume that they would continue doing this forever. And that is the law of conservation of energy. And I think it's so crazy that if we didn't have this loss of thermal energy, that these spheres would just be tick-tocking forever. That was not an ad for TikTok. Same with this pendulum. So can I pause this GIF? Choop. Okay, so if I use my hand and I lifted that sphere up at a height and I released it, then this would swing back and forth. And it will never gain energy either. So how high does it go? It goes about this high, and it swings to this side and it goes about this high, and it will never gain height. It will always, I just drew it wrong the first time. It's about that high. So it will never all of a sudden go woo and get higher. It cannot create energy. So that's the law of conservation of energy. It cannot be created or destroyed. But it can be transformed or transferred. So just like in this case, the energy is transformed into thermal energy and leaves the system. And in this case, the energy is changing from gravitational potential energy. At the bottom, it's moving really fast. It's got kinetic energy. Anytime it's moving, it's got kinetic energy. And it's just going to be sort of changing forms forever. Now, in real life, it's going to be colliding with a bunch of air particles. And every time it collides with an air particle, it's going to cause those air particles to move. It's going to transfer energy to the air particles. Remember, transferring from one object to another. And in this way, this pendulum slowly over time will come to rest at the bottom because it transferred its energy outside of the system. Okay, so that's the conservation of energy. I hoped I've used the words transferred and transformed a lot, and I want you to be able to do the same. So practice looking at different systems or scenarios and going, this is how the energy is transforming, or this is how the energy is transferring.